Your night in California, here we go. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Liftoff of the Atlas V, carrying JPSS 2 and LOFTID, a new weather observatory for our planet, and a test for planetary exploration.
Atlas VU has gone to closed loop control.
Yeah, Gerald, as you heard Omar Baez say, LSP 100 on its way also. We're very happy for this 100th mission, the Launch Services Program. Let's listen in as Jesse Gonzalez.
And coming up on 30 seconds into flight, vehicle is a half-mile in altitude, 2 miles downrange, traveling at 160 miles per hour. And passing 45 seconds of the flight, continuing to see good operating parameters out of the RD-180.
The power of the Atlas V RD-180.
Coming up on a minute into flight, the vehicle is ending its roll maneuver, and vehicle body rates are looking good.
Getting ready and approaching Mach 1.
And passing through 80 seconds into flight, Mach 1, Atlas V is now supersonic.
That's 769.
And vehicle is now passing through max Q, maximum dynamic pressure.
769 miles per hour, 121,234 kilometers an hour. Going through the area of maximum dynamic pressure on the vehicle.
And passing 100 seconds into flight, seeing the RD-180 throttle back as expected. Engine response continues to look good, and vehicle body rates continue to look good at this time.
Throttling down just a little bit to reduce the stress.
Coming up on 2 minutes into flight, the vehicle is now 12 miles in altitude, 7 miles downrange, traveling at 1,500 miles per hour. And passing 140 seconds into flight, the vehicle has gone to closed loop control, continuing to see stable body rates throughout the boost phase.
So the rocket was flying in a trajectory that's programmed in, but now closed loop is taking positional feedback from the rocket sensors to get it into the proper line for trajectory. It's going to maintain that ascent line. Beautiful shot there on board.
And RCS is now pressurizing to flight levels.
A shot from our infrared camera.
And the reaction control system has reached flight levels. System response looks good. Vehicle body rates continue to look good as well. Seeing good response out of the RD-180 engine.
Going to start cooling down that Centaur engine in the second stage to prepare for its super chilled propellants to flow through the booster.
About 3 minutes and 15 seconds into flight, vehicle is now 53 miles in altitude, 67 miles downrange, traveling at 5,800 miles per hour. And now seeing the RD-180 throttle back to maintain a 5.0 G acceleration limit. Engine response continues to look good.
We're just seconds away now from booster engine cutoff.
And we did see a good response on the Centaur systems as it completed boost phase chill down. And we have BECO, booster engine cutoff. And we have successful stage separation.
With stage separation, and now onto the Centaur.
On the RL-10. And we have ignition for the first burn. RL-10 start parameters look good. And we have good indication of payload fairing jettison.
Saw a shot of that booster floating off into space.
Yeah, you can actually see the 4-meter fairing going by there too on the video. That's a great thing. Looking at the telemetry data, RD-180 performed very well on the first stage. Separation was clean. Payload fairings, you can see on the infrared video there on the screen, the booster falling away and the two little fairings. Pre-start.
Coming up on 5 minutes into flight, this first burn will be about 13 minutes in duration, the first of 3 burns for today's mission. Continuing to see stable RL-10 chamber pressures at the beginning of the burn. And also seeing stable body rates following payload fairing jettison.
RL-10's performing very well. Pre-start was good. Ignition came out very well, as we saw in the video, and as the Centaur continues to burn nominally, body rates on the vehicle look very good with payload fairing gone. JPSS-2 exposed to the environments of space.
As it warms the motor catalyst beds for operation.
Explain quickly what a body rate is.
So the body rate's the attitude of Centaur as the vehicle is moving through space. We're trying to keep everything as stable as possible. So we have an X, Y, and a Z body rate on the Centaur, and the flight computer and the RCS system continue to maintain that as we move through to get ready for separation.
And now we're moving to ULA's real-time animation.
6 minutes in flight, the vehicle is now 250 miles in altitude, 430 miles downrange, traveling at 9,400 miles per hour.
The animation is informed by real-time data. As we watch the RL-10 burn and the Centaur fly, at the top of the vehicle is JPSS-2. And there you're looking at the RL-10 as it continues its burn.
And coming up on 7 minutes into flight, continuing to see stable performance across all Centaur systems, stable tank pressures, good performance out of PU, and some minor roll adjustments as Centaur optimizes the telemetry link.
Centaur with plenty of performance to get there.
Plenty of performance, and everything's looking great. As we heard Jesse say, everything is performing nominally as we get ready to continue this burn for separation.
We're going to keep watching the data and listening to the launch team as we track the performance of the Centaur getting JPSS-2 into orbit. But in the meantime, let's send it back to Megan.
If you're just joining us, I'm NASA's Megan Cruz, bringing you live launch coverage from Vandenberg Space Force Base along the central coast of California. Just about 7 minutes, 34 seconds ago, we watched as a United Launch Alliance Atlas V rocket lifted off at 1:49 a.m. Pacific time, and it was a spectacular sight. What a clear night, no clouds in sight. That rocket just lit up the dark sky. It's flying 2 important missions today. The primary one is to send JPSS-2 into orbit. It's the National Oceanic and Atmospheric Administration's newest joint polar weather satellite. The secondary mission is called LOFTID, which will demonstrate a new type of heat shield that inflates for atmospheric reentry. We're going to stay with you live for every important mission over the next 2 hours.